Thank you so much for having me here. I feel like I've had a very long dialogue with the National Academy of Sciences, starting actually in 1985. So it's a real treat to be here. E.H. Gombrich famously wrote, "In art history, the word evolution is a good deal more than a metaphor." He then proceeded to talk about how form adapts to function, processes of mutation and selection, and then of the survival of the fittest forms in art as in biology. Since Gombrich wrote, certain debates have taken place about evolution, even among Darwin's followers. For example, structuralism stresses that organisms are shaped by developmental constraints comprising universal laws of pattern formation and emergent properties of complex systems. By contrast, mainstream neo-Darwinian evolutionary theory emphasizes the role of selective adaptation in shaping the evolutionary history of organisms. So, as an artist, I was asking the question, to what extent should the roles of adaptation and selection be considered be considered relative to other factors such as genetic drift and developmental constraints? In this talk, I focus on how art can explore some aspects of these constraints. There are three main ways that I have explored the subject of constraints that are operative in evolution in my art. First, explorations of constraints on attention, such as capacity. Second, explorations of the morphing of forms and patterns through physicochemical constraints and rules such as cellular automata. And third, comparisons of biological evolution and cultural change, for example, niche constraints resulting from competition. For example, one of the basic constraints on the brain's attentional system is its limited capacity. If it's already filled up by attention to a particular task, other tasks may not be as consciously perceived. Can art then redirect visual attention to sensory signals that had been unnoticed? Inattention blindness is the phenomenon of not being able to see things that are directly in front of you. It manipulates the viewer through salience and misdirection and involves higher level cognitive functions. In other words, it's like being a magician. Some of you are probably familiar with work by psychologists Simons and Chabris, who provided a model of the limits of human attention. What they did was they made a videotape of a basketball game between teams. Experimental subjects were asked to keep silent mental counts of the total number of passes made by one or other of the teams. During the game, a figure in a full gorilla suit appeared, faced the camera, beat its breast, and walked off the court. And surprise, more than half of the people who were the subjects failed to notice the gorilla at all. Now, I'd like to show you an art experiment that I conducted in several galleries, and I'll direct some questions to you afterwards. There it goes. So here's your task. Count the number of times you see the Queen of Hearts. When you see the hands, get ready to start counting. Okay, I'm stopping it there. How many Queen of Hearts did you count? You can shout it out if you know the answer. Anybody? I hear 17. Okay. How many of you noticed the disappearing objects on the left side? How many of you could identify what they were, what they are? Those are objects that were looted in 2003 from the National Museum of Iraq. And on the right were some people that went through the gallery where I had the exhibition. My, my exhibition, Stealing Attention, involved two components: observing if viewers watching an animation in a gallery could be distracted from noticing the disappearance of stolen museum antiquities, the targets, by the overlaid flashing images of a card game, which were the distractors, and then observing whether repetition of the depicted targets throughout the gallery installation could facilitate an attention switch that allowed viewers to perceive the targets not originally noted in the animation. The reasoning, my reasoning for doing this, was that the informal learning taking place through conceptual cueing might cause viewers to recognize the overlooked targets, and that's also true of the repetition itself. I did the animation, I designed it with a neuroscientist, Mickey Goldberg, who is soon to be a member actually of the National Academy of Sciences. He's up at Columbia. So the design was that a task was provided at the onset: count the number of times the Queen of Hearts appears. The program then randomized the order of the disappearance of 10 images of stolen antiquities represented as being on shelves in the National Museum of Iraq. After all the antiquities were removed, an image of rubble appeared representing the looting of the museum. And these are some of the static artworks that were in the installation. And as you can see, the images of hands are repeated to the right over there, and on the lower part, on the right side, Connie Baghdad. On the lower right, their hands, and also towards the center. And behind these cards and throughout this abstracted picture of a museum are some of the antiquities being stolen. In addition, there was a room that I painted black and had a single shelf with printouts from the database of missing objects from Iraq. So this was, in a way, a giveaway to people as they moved around the exhibition, that they could identify the targets and then see them for those who had not seen them the first time. But let me provide, and this is another one. The construction of an installation in animation allowed participants to experience the constraints on the attention system, showing the animation within the experimental context of a gallery setting, provided a way for viewers to experience a common failure of perception, along with an opportunity to reflect on the experience. Let me provide a little bit of background. Inattention blindness is, in fact, an old topic in art. Bosch shows the shell game here, The Conjurer, around 1475. And if you see the pickpocket at the far left is tucked away at the left edge, while the person bending over is totally distracted. These paintings also show the card thieves. You see the Gelator and the Caravaggio. I had heard a recounting by Donnie George Yucana's assistant about the looting that took place. He was the Director General of Iraq's National Museum and responsible for recovering many looted objects during the chaos that followed the US invasion of Iraq in 2003. He movingly relayed how during the thieving, he was approached by one of the looters In fact, the man informed him that he was not a looter, but had pretended to join them with the goal of rescuing the most valuable antiquities and then returning them to the museum when it was safe. And that is exactly what he did. Shortly following Donnie George's talk, I went to the nearby Kimball Museum in Dallas, and I saw the paintings, these paintings there. In that moment, I made a connection between the stolen antiquities and the Bush administration's own con game. The distractors were the non existent, for me, the non existent weapons of mass destruction. So, the main questions asked by this installation, the main question is, can art overcome the constraints on the attention system and redirect the viewer's attention? After viewing the entire installation and then reviewing the animation, over 60% of the viewers who had not originally seen the targets were then able to do so. So I concluded that art under particular circumstances can train attention, and that the attention set adopted by the observer can sometimes control which objects in the visual field receive priority. Virtually nothing is perceived without attention. Artworks tend to stress the social, emotional, and metaphorical dimensions more than science. By manipulating these dimensions, art, like magic, can work with the constraints of vision and shift the focus. Now, fairly quickly, I'm going to show you two other ways that I've used aspects of evolution or evolutionary theory in my work. Darcy Thompson and Stephen Wolfram, from very different times, have helped to foster what is known as generative art. They both suggest that the processes of growth and development within the growing organism make it either easier or harder for particular structures to arise, and artists have exploited that. And they've done it by using what is known as cellular automata, which are self-replicating, self-organizing groups of cells that live, die, and form patterns based on the simple rules that instruct each cell to change its behavior in accordance with the behavior of neighboring cells. So they can essentially be described in terms of constraints. Wolfram believes that the CA mechanism can explain recurrent patterns in nature, like mulla shells, but they're critics of this viewpoint. But my point today is that artists such as John Simon Jr. and Leo Villarreal have both made use of them, as have I in my work. In this work, I actually used an image that I scanned from bacteria I had grown, and then incorporated that scan along with the image of dying cow of mad cow disease, and then exploded the whole thing with the use of cellular automata. And then the third component I wanted to talk about is comparisons between cultural and biological evolution. And the premise of Temkin is that cultural artifacts like genes and language reflect their history. And art can show the impact of our technologies in a very broad human scale framework. Elements can be viewed as dynamically evolving large scale information systems, and patent citations suggest the network of influences of specific inventions over time. And this is actually Niles Eldredge's evolutionary tree of cornets. The horizontal axis shows relationships among different models. They were valve systems he collected, and the vertical branches correspond to periods of manufacture of these models. The curved lines show the transformation, the horizontal transfer of information. And a similar kind of diagram was made by Raymond Loewy, who compared manufactured objects at different times. And I did something very similarly. You can't see this here, but I think I have some detail. Yes, and these are incorporating patents of different manufacturing companies active and causing environmental changes in the Arctic. And I'll conclude with this was a collaboration, effectively a collaboration. I did my installation, but then Liz Lerman had her students develop a dance to interact with it, which was quite exciting. So, what I'd like you to get from the talk today, these were my conclusions, that increasing numbers of artworks have counterparts in science experiments. Some of them address evolutionary subjects and place technology within the large framework of evolution. And thirdly, artworks engage such subjects in very different ways from the sciences, often creating experiential and emotional situations that engage people. Thank you very much.